Hi everyone. Today let's talk about the chemical equilibrium. Before I introduce this concept to you, the first thing you should know is that almost all the chemical reactions are reversible. For example, as we mentioned last week, under the high voltage condition, the oxygen can be transformed into the ozone. But it doesn't imply that all of the oxygen can be converted into ozone. That is, the transformation of ozone to oxygen also occur in this system. Actually, in this system is a mixture of ozone and oxygen. And let's take another example in our daily life. When you open a bottle of Coke or champagne, what will you feel?
Spirit.
And spirit and
Lots of gases.
gases. What is?
Carbon dioxide.
Yes, real excellent.
I call it
actually,
spirit.
Yes, okay. You can feel the gas bubble. Yes, actually it's carbon dioxide. And in this case, there is a chemical reaction. The carbon dioxide plus water can produce the carbonic acid. And also is a reversible chemical reaction. And when we produce the Coke, we will dissolve enough carbon dioxide into water. And also because it's a reversible chemical reaction, this kind of acid can be decomposed into carbon dioxide and water. And that's why we will feel the gas bubble will be open a bottle of Coke. Yes. Next, can you give a guess, under which condition or states we can say a chemical reaction can reach into a chemical equilibrium? Yes, just use your imagination.
I think the concentration of the reagent and the products is stable.
Okay, great. Yes, that's a stable concentration.
I have a question.
Yes.
But it means that the inputs of the system is equal to the outputs of the system. For example, when I put water in as an input in a chemical reaction and goes outside any other element, are the same input and output amount to
Yes.
get stable?
Yes, actually, the carbon dioxide dissolved in water and this kind of acid decomposed into carbon dioxide happens at the same time. Yes, so it's reversible. And the chemical equilibrium actually is a state in which the concentrations of the reactants and the products are not changed with time. And in this case, we can also say that the transformation rate of oxygen to ozone is equal to the transformation rate of ozone to oxygen. So in a chemical equilibrium, we can also say that there's no tendency for the qualities of the products and the reactants to change. So next, there are three factors can influence or break a chemical equilibrium. Do you know which are the three factors, or can you just give me a guess? The three factors can influence or break
Temperature?
a chemical equilibrium.
Temperature?
Yes, temperature.
Concentrations.
Yes, concentrations. And
Pressure.
yes, pressure. Yes, you are really good at chemistry. Yes, actually.
Does
you
volume
can-
come under concentration?
The concentrations, yes, you can
You
change
can
the
change
concentrations by adding or removing the products and reactants from the system.
Or volume too. The volume you can change the volume of the system and change the
Yes,
concentration.
actually, sometimes when you change the volume, the concentrations can be changed as well. Yes. And first, let's talk about the pressure because it's a very interesting one. In the principle, it says that when we raise the pressure of the system, the old chemical equilibrium will be broken to form a new chemical equilibrium. And in this new one, the concentrations of the products and reactants are totally different from the former one. Understand?
Mhm.
It means it's another chemical equilibrium. And actually, when we raise the pressure of the system, the chemical equilibrium will be broken and the chemical reaction will move to the direction of decreasing the gas volume. Yes, for example, the hydrogen can be burned by the oxygen to form the water vapor, and means is a gas, and it's also a gas. And we can find that two hydrogen plus one oxygen can produce two water vapor. Is right? And the gas volume of the reactants is 3, and of the products is 2. So if we raise the pressure, this chemical reaction will move to which direction? To form a new chemical, yes, this, yes, because the gas volume is decreased. And so let's review today's class. First, we know that almost all of the chemical reactions are reversible. And the next, the chemical equilibrium is a state that the concentrations of the products and reactants are stable and not change with time. And second, there are 3 factors can influence or can break a chemical equilibrium. And next class, I will talk to you about the other 2 another factors can influence a chemical equilibrium. Yes, that's all for today. Okay.
Questions?
You have question? Any questions?
Yeah, I have a question.
Yes.
So this reaction is in the closed system or open system?
Yes, actually it's a closed system, yes. When we say a closed system, when we say system actually is, in most cases, it's a closed system in chemistry, yes.
But is the same concept as pseudo-established systems? Pseudo?
Yes, a kind of.
Kind of?
Yes.
Was one of the systems that I would like to know more about.
Okay. It's very complex concept in chemistry, so I just simplify it, yes.
Okay.